I am so happy to be able to talk with you because I really am almost paralyzed because I'm really ignorant about climate change. I'm really confused about it. And I've been looking forward to this to get a chance to ask you some sort of basic things. It's also, I think, I'm not alone in this because it's quite. There's so many elements to this that have to do with what's the biggest animated story of our time in many ways. This is getting very, very, very hot, and then it will flood, and that's this apocalyptic, strange thing that may or may not be true, and it's a huge thing to carry in your mind. So, I want to just start with some of the things that came out of Paris. We all kind of followed that as well as we could, and I didn't really know whether to be happy or not about the outcome of that. So I know that's a sort of silly way to start, but were you encouraged by that, or what did you make of the whole 2-degree thing?
So, yeah. Okay,
Yeah.
so I mean, let's start off. I mean, the whole thing really is very complex because it is very complex. There are some simplifying things that make it tractable that we can talk about. But when you're talking about a system the size of the planet, you're talking about influences that range from the sun to volcanoes, from the top of the atmosphere to the bottom of the ocean. There's a lot of stuff that's going on. And you just need to look out of the window and see the complexity that is the weather system, the climate system, one winter from another. Last winter was very cold. This winter is going to be quite warm.
Yeah, Merry Christmas.
It's
really strange, no?
I mean, so strange is normal, right, when it comes to weather, because it's so variable, and then trying to pull out a long-term trend out of that, to pull out predictability for decades into the future, hundreds of years into the future, it's an enormous challenge. Now, we've been working at this for a while, and one of the other speakers in this series, Jim Hansen, who did have the job that I now have, was very vocal about this way back in the 1980s, 1988. There was a really the first time that global warming was a front page story. We've been thinking about this, in a public way for many years, and so let's go to Paris. Paris was the Conference of the Parties number 21. Okay. 21 conferences of the parties. You'd think they'd have worked it out by now, how to make it work. But it took them 21 years, in fact, to get to this point. And they had a lot of disappointments in the way. They had some, I think, kind of naive ideas about how we would go around fixing this at the beginning, where the complexity of it wasn't really apparent, because there's complexity in the physical system, so the clouds and the rain and the wind and the oceans, but then there's also complexity in our systems, like our society, how we make energy, how we think about things. There's a kind of sociological complexity, which quite frankly, I think at the beginning people did not appreciate. And so getting 197 countries to all sign up to anything, it doesn't happen, right? I don't think there's anything else in the world where 197 countries have signed up, to an agreement. The treaty on the rights of the child has not got as many people signed up for that. Really? You'd think that was pretty universal, right? So it's getting anything.
Well, that's encouraging.
Well, yes, I think so. I think getting anything is encouraging.
Yeah.
Are what people are agreeing to do, is that commensurate with the size of the problem that we have? No. It's not. So if you want to look at it as a kind of glass half empty, then you say, well, they agreed to something, but it's all motherhood and apple pie, but it isn't really going to do enough. And
What would be
that's
enough
true.
in
well,
Paris?
okay, so we could get that.
Yeah.
That's a more. We'll get to.
We'll
that.
get there.
We'll get
Okay,
to that.
good.
But what people, I mean, right now, what people have agreed to do is not enough. Yeah. But then, the other part of this is that this is a chronic problem, right? So let me make an allusion. If I trip falling down these stairs and I break my arm, I have an acute problem. I have to deal with it right now. I put everything else aside. I go to the emergency room. I get a cast. I have it to do it right now. Nothing else matters. Okay. But also, when I'm walking down the stairs, I have higher cholesterol than I should have, and I am more overweight than I should be. Is that something I'm going to go to the emergency room for? No, it's something that is much more living, hopefully, long-lasting, and it's something that I really should do something about it. But do I need to really start right now? I mean, right now. I mean, can I not just have one more beer? Maybe tomorrow. You know what? Actually, tomorrow there's a party.
Kind of busy. Yeah.
Next week. Well, for next week, it's the holidays, right? So, maybe after the holiday, in the new year, right? Okay. So you know where that's going. Procrastination is much, much easier with chronic problems. Climate change is a chronic problem, right? It's not something that's amenable to a big bang fix. We all agree to do something and then it's done, right? Some other problems are like that. So when we had the acid rain problem back in the 1970s and 80s, that actually was a much more straightforward problem.
In what way? What was that? Can you just summarize the acid rain problem?
Oh, so when you burn coal, there's often a lot of stuff in the coal. So the coal that was being burnt at the time was very high in sulfur, right? And when you burn sulfur, you make sulfur dioxide, and sulfur dioxide in the atmosphere becomes sulfuric acid. And it makes little particles, and they get washed out in the rain. And so downwind of all these power stations, you're getting basically sulfuric acid poured into your watersheds and into your lakes. And as you might imagine, that's not very healthy for the health of those ecosystems. And so that is something that was building and building and building all the way through to the 1970s and 1980s when it became an acute problem. And there was a lot of discussion about how to fix it. In the end, they set up a trading scheme where they were allowed to emit a certain amount, and then they would pay if they emitted more, and then they kind of ratcheted down the amount that they were allowed to do.
Did that solve the problem?
And in fact, it solved the problem something like 40 times cheaper than anybody thought that you could have solved the problem. It was solved very, very quickly, within a matter of a decade after that legislation was passed. And so now in this country, acid rain is really totally a solved problem. Now in Beijing, in China, it's not, right? Because that's a whole nother level.
But it's a solvable problem.
But it is, technologically, it's a solvable problem.
So these solvable problems, I mean, ozone holes are solvable problems as well, no?
Yes.
And
so
can be solved and are solved.
We are solving.
Solving.
Yeah, so there are timescales, even with solvable problems. And the timescale for the ozone hole is in the many decades. So we've kind of bottomed out in terms of ozone holes. So it's going to get better slowly after this. Yeah. But that was both a great lesson for climate change, and also a great lesson for our ability to predict what's going to happen,
right?
Because we didn't, right? So the ozone hole, right, the big polar Antarctic ozone hole was not predicted, right? So back in 1974, they worked out the chemistry that connected the propellants of aerosol cans and refrigerants to ozone depletion in the stratosphere. Mario Molina, Sherwood Rowland, they won the Nobel Prize for that discovery. And all through the 1970s and early 80s, people were saying, okay, well, let's work out the consequences of this. And they would make models, they would make predictions, and they said, well, look, the ozone is going to go down and down and down, and there's going to be more UV, and there's going to be more cancers, and this is something we should deal with. And so, there were small efforts. There were efforts to get people not to use spray cans. There were efforts to get people to switch to roll-on deodorants and the like. And people started talking about it in a diplomatic way. But then in 1984, people started reporting levels of ozone in Antarctica that were almost zero. And that was not predicted. And so, they were there 2 winter seasons, and they said, well, no, it's happened twice now. Something is going on. They published that. It was a huge deal. NASA, who we've both worked for, said, well, hold on, we have a satellite that should be measuring that stuff. Why did that satellite not see what's going on? So they went back to the satellite, and it turns out that they had just never expected any numbers to be that low. So any time a number came in that low, they just said, well, that can't be right, and threw it out. And so they went back, they reprocessed it, and they said, oh, no, you're right. No, there's this huge hole in the ozone layer. Oh, my gosh. And that was, a surprising thing, because we don't understand everything about the system. Right? It is a complicated system. And we're pushing that system into places where it's never been observed. And so odd things are going to happen.
Yeah.
Kind of got off topic there. Where were we going?
Thanks for the acid rain departure. So back
yes.
back to the
So solved environmental problems, right? So environmental problems can be solved. Yes.
Yeah,
yes.
I mean, but you, of course, define climate change as something made so much interplay of so many huge systems, and so in some noble universe is climate change not just containable but solvable, or is it just kind of too late to solve?
So it's never too late. That's not just a cliche. That's actually true. We're making decisions now that are locking in future emissions, and we will always be making those decisions, right? So there's never going to be a point at which we should not make the right decision. We should always be making the right decision. So when people talk about this, whether you use a metaphor of well, now we're safe and now it's going to be dangerous, or there's a tipping point and then then it's the end of the world. I don't think that those really reflect the physical reality, and I don't think they're very useful ways to think about the problem. Because if you think that everything is fine until there's a tipping point, then that just builds complacency because nothing is going on now. And then once you get to that tipping point, well, then it just breeds nihilism because there's nothing you can do. You've already gone past that.
But isn't Brazil running out of water, and Beijing it's impossible to see?
Yes.
Aren't those tipping points? Or they're just
well,
not?
they may be societal tipping points in the same way that the smog in London was a societal tipping point for pollution controls in the UK, in Europe, in Japan, in the US. Sometimes big disasters can lead to very positive reforms that make things much more sustainable. But the thing with this chronic problem that we have is that we have to build a sustainable way of talking about it and a sustainable way of thinking and dealing with it. And when people are just dreading, the tipping point, that's not a sustainable conversation.
No, that's just a series of panic.
Yes, exactly, and that's no good.
And
at
then,
all.
as you say, back to some sort of complacency, because that's what I thought about the 2 degree.
Yeah, 2
thing.
degrees.
People are like, wonderful. Well, okay, that's solved, and then and
people have no idea what that 2 degree number means.
So tell us what it means.
So I don't know. There's about 200 people in here, 100 people in here. The temperature in this room has probably increased by about 2 degrees since we've been sitting here, because each one of you is a 100-watt heater, just kind of heating up the place. And none of you have gone extinct yet. right? The chairs have not melted. Nothing terrible has happened. Because on the scale of our everyday lives, 2 degrees, it doesn't really matter. On the scale of a day, 2 degrees is really nothing. Like today was, maybe 5 degrees colder than it was yesterday afternoon. But, nothing terribly dramatic has happened. Part of the complexity of the system is that there is a lot of variation. But that means that when you average over the whole planet, there actually isn't very much variation, because generally speaking, where one place gets warmer, another place gets colder. It's like kind of the winds just kind of move things around. So you have to think on a different scale when you're thinking about the planet. So a good scale to think about is that of the ice ages. So many of you are probably aware that the last ice age was about 20,000 years ago. And where we are right now was covered by an ice sheet. That ice sheet was hundreds of feet thick. In Central Park, if you look at the rocks in Central Park, all of them have lines, scratches going across them. Those are glacial striations from where the ice sheet was pushing stuff over those rocks. And it pushed it all the way down to Brooklyn, Prospect Park. If you start at the top of Prospect Park near Grand Army Plaza and you look down, and there's a little kind of halfway down, there's a set of little hills, and that's the terminal moraine. That's where the glaciers ended, right? So that's where they pushed all the stuff and they just ended there. And they ended there around 20,000 years ago, and it took them about 10,000 years to recede, and obviously now they're all the way back into Greenland and a long way from here. So that was a very different place. That was a very different planet, right? Where we are now, covered in ice, all the way to the south, tundra, and no pine forests, no lush maple groves or anything like that. All of that stuff was much further to the south. Sea level was about 400 feet lower than it is now, because of all that water was in the ice, right? And so the question that you asked is, well, how cold was the planet then?
Yeah.
Right, but do you have a guess how much colder the planet was? Pop quiz.
Maybe not that much colder.
Not that much colder is the right answer.
3 degrees colder.
It was actually about 5 degrees Celsius colder. So Celsius, you multiply by 1.8, so it's about 9 degrees Fahrenheit colder at the depth of the last ice age, when we had all this ice, and it was a very, very different planet. The 2 degree number that we're talking about in Paris, that's about 3.6 Fahrenheit. That's kind of halfway to an ice age, but in the other direction. The worst case scenarios for the end of the century, right, where if we don't do anything, if we just continue to burn as much fossil fuel as we can, you're talking about 5 degrees Celsius warmer by the end of the century, 9 degrees Fahrenheit. That's a whole ice age unit, right? So that's as warm in the end of this century as the ice age was cold compared to today. That was a totally different planet.
And is that irrevocable? So it keeps getting warmer. Let's say,
and that it doesn't just stop in 2100.
Exactly.
Course, no.
Yeah. So 20,000 years from now, what would Central Park look like if that is the direction?
So that's interesting. So the ice ages come on a cycle.
Yeah.
They're controlled by these very subtle wobbles in the Earth's orbit. You might not know that the Earth is wobbling. Can you feel it? No. Okay. No, it's a very slow wobble. It wobbles on timescales around 20,000 to 100,000 years, and that really sets up the pacemaker for the ice age, because the orbit itself is an ellipse, right? So it's not perfectly circular, and that ellipse changes shape. If we have a circular orbit, then where the difference of the seasons is less, and that makes a big difference to whether you can grow an ice sheet. So those cycles have been going on for the last 2.5 million years, and if it hadn't been for us, they'd continue. But we are a geological force now, so we have said no no more ice ages. That's a good thing. But there's a price that we're paying for that.
If you had to call what's going on now something, would you go towards the word like collapse?
No, I would go, because it doesn't feel like it's collapsing, right? Not here.
I mean, when
in other places, it
like
can feel
Miami.
that. See, yeah. So I was in Venice actually, relatively recently, and Venice and Miami and Virginia and Chesapeake Bay all have something very much in common, which is that it floods much more often than it used to. And we were in Venice, and there was an acqua alta, which is a high water. And it's very pretty because, St. Mark's Square fills with water, and you get these very nice reflections of the buildings. But of course, it's a disaster for the city. They used to have acqua altas back in the 15th, 16th century, but it would happen once every 50 years. As Venice sank and as sea level rose, something that was very uncommon became more and more common. And so it became once every 20 years, once every 10 years, once every year. Now it's 20 times a year.
Yeah.
And, you can see these graphs. And the same thing is happening in Miami. So they call them the king tides in Miami, nuisance flooding. But what's happening is that they are happening far more frequently than they used to. And that's exactly what you expect as the water rises and generally the cities sink under their own weights quite often. If you're geologically lucky, like Stockholm is geologically lucky, they're still rising from the last ice age.
Oh, really?
So they're not bothered by this, okay? Yeah. But if you're geologically unlucky, like Chesapeake Bay, and you're sinking from the last ice age, well, that's just a triple whammy for you.
Right.
And climate change just aggravates the things that are already causing you aggravation.
400 feet is a huge number of feet.
Oh, enormous.
So Manhattan is slowly sinking from the last glacier, last ice age.
No, so actually, where we are now, we rose a little bit because the weight of the ice was removed from us, and we rose a little bit. But obviously, all of the water kind of filled that in. So you can actually trace the Hudson, the canyon of the Hudson, out maybe 200 miles on the seafloor, right? Because you can see it etched its way out all the way through the continental shelf. And that's all now totally buried underwater. And with more ice melting, then more of the Hudson will be buried underwater.
And so tunnels will start popping up out of the bed, perhaps.
Well, we saw with Sandy that it doesn't actually take that much extra water to overtop these things. We had a storm surge in Sandy of 13 to 14 feet, and that was enough to fill all the subway tunnels and take out a huge amount of infrastructure, electrical infrastructure on the Lower East Side, and a lot in New Jersey, Hoboken. And it's not that we expect 13 feet of sea level rise from climate change, but we do expect 2 feet, 3 feet, perhaps 4 feet, 5 feet. And every extra foot of sea level rise from climate change means that every time you have a storm, then it's that much more damaging. And the damages go up exponentially because, if the drain is at 13 feet and the water goes up to 12 feet, it doesn't cost you anything.
What happened to that dike system that was going to be designed for New York?
Well, it's still on the table.
Yeah. Is that realistic at all to just build dikes again?
Not everywhere, no.
Here?
No. Here?
What about here? What do you think?
It is. So, again, let's think about the numbers. The amount of damage that Sandy caused around the area was around $50 to $60 billion. The cost of a barrage system, and it would have to be a complex one. You'd have to have one across the Verrazano Narrows, and you'd have to have one across Long Island Sound. Would be about $20 billion.
It's a bargain.
Well, and then you say, well, but that Sandy won't happen again. No. So something like Sandy will happen again.
Yeah, Sandy will happen
At
again.
which point people will start thinking very strongly about
Do you
our
think
system.
2 Sandys would do it?
Yes,
Do you?
because in Venice, what happened was these things kept happening, and now they've actually built a barrage system, which
Does it work?
nobody knows.
Okay.
So they've almost finished building it. I think they think that they'll be able to turn it on in a year or so's time. It's called the Mohs project. But it's
so
been
how does it work
enormous.
roughly?
So it's actually the engineering is really quite good. So they've dug these big holes. So Venice is in a lagoon for people who haven't been there. There's a number of barrier islands. Venice is a number of islands sitting in the middle of the lagoon. And between the barrier islands, what they've done is they've dug big trenches. And they've put these enormous doors, effectively, that they filled with water, so that in normal operation they're flat along the bottom, so you don't see them. But then they pump air into them, and as they pump air into them, they're supposed to pop up and then block the high tides or the whatever is causing the water to rise from coming in. And in demonstrations, they do pop up. But nobody has actually tested it to see if it would actually prevent an aqua alter yet. But that's cost them, $50 billion over many, many years. And this is Italy, so everything costs 4 times what it should do. And it takes 4 times as long.
Everyone has so many relatives, You've got to help them out.
So, I mean, it makes the point that adaptation to change is not free, right? So decisions to do nothing is not a decision.
Yeah.
Right.
Yeah, but getting back to this sort of giant picture of sort of increasing series of emergencies and doing things like building dikes and smaller solutions, holding to that 3-degree or 2-degree thing will get us where will that get us in the ideal situation? And do you see that do you see that working?
So one of the things that we do at my lab is that we collate temperature data from around the world, from all the oceans, and we make maps every month. We kind of update the map, and every year we say, well, was that a warm year or was that a cold year? Usually it's a warm year. And this year is going to be a record-breaking warm year.
As was last year, right?
Funnily enough,
the last
yes.
how many years have been record-breaking?
Yeah, so 2014 was a record warm year, 2010, 2005, 1998.
Okay.
Curiously enough, when Jim Hansen first said global warming in 1988 was a record warm year. Now it's not even in the top 20.
Ooh. Really? Wow.
Yes. So things are warming up.
Yeah.
And this year will be the first year that it's 1 degree warming above what it was in the 19th century. And that's halfway to that point. And so, we're closing in on it. And the impacts, we're already seeing impacts. We're seeing impacts in the Arctic. You've been up to the Arctic. You're seeing impacts in retreating glaciers in Greenland. Greenland's losing about 250 gigatons of ice every year. The sea ice, the floating ice in the Arctic is retreating. We're seeing the lowest levels of ice there that we've ever seen by 40, 50%.
And ice won't come back, right? It won't.
It won't come back until it gets cold again, and it's not going to get cold again.
It's not going to get cold again.
No. That's not to say that we won't ever have a cold day here in New York, but the Arctic as we knew it is
it's not a renewable thing.
Changing. No, that's.
And when you say never,
I mean on a scale, on a human scale. I mean, so in the next hundreds of years. So maybe in 10,000 years, who knows what will be
Another
happening
ice
there.
age
Yes.
kind of situation, possibly.
Yeah, possibly.
Or
I mean,
not
the
likely.
next ice age isn't really due for another 30,000 years. So, but that's that's not a time scale that we conjure with, right?
I don't know. In my brief time at NASA, I was really impressed to see that one of the rooms had a 10,000-year timeline on a whiteboard. And I'd never seen that, because I work in projects that are like maybe a year out. It's like, as a complicated timeline. This is a 10,000-year timeline.
Yeah.
And so, I enjoy thinking of that, because I can't really imagine what, we've been around for an awful long time. I can't, and I can imagine the human population becoming almost nothing and then growing again. I mean, I don't know. It's nuts. It's part of my sort of story, of planetary story that I tell myself, I suppose.
Right.
Just because collapse seems to me very likely. I don't mean to be dark. I am a really pessimistic person, but it does seem like awfully hard to avoid this. Are you more optimistic than I am?
I'd like to think so, but I noticed that your glass is half full and mine is empty.
Yes. I'm just going to give you my glass. Let's even it out.
Yeah. I try and be optimistic. I just had a child,
Yes.
a 3-month-old, and so that's a definite statement
That's a
of
vote.
optimism,
Yeah,
right?
it is.
And I have this conversation a lot. People ask me, how do you deal with this? Like, what should we think? How should we think? Like, are you possible? And I'm a basically optimistic person, not because I think everybody is suddenly going to have a kumbaya moment and realize what's going on, but that in the end, societies make. Oh, I don't know. That's not true. I can't even tell myself that's true. I hope that that's
We're
true.
expecting honesty here.
That societies have made positive changes.
Yes,
They have. They haven't always made.
I couldn't agree more.
Right.
But is this is an awful lot of societies who all have to make a giant shift, and do you think that giant shift? Maybe are we exaggerating the amount that the shift needs to?
No. The shift is giant. It's not a question of recycle your cup and everything will be fine. It's not a question of use an LED light bulb and everything will be fine. It's really a question of we need to find different ways of generating our power. We need to find new ways to generate power for people that don't have any power. And those are enormous engineering challenges. They're not insurmountable, but they're enormous. Like, so right now, we get about 30% of our power is from burning coal. Almost all of our transportation is from burning oil. A lot of our heating is from burning oil and from natural gas. All of those things are contributing to the problem. And they're not something that you or I individually can fix. Like, we can't fix New York State's energy power grid, right? Those are big issues that are going to take decades to come around to dealing with. But then, we started off with Paris, right? We had 197 countries all sign up to say, yes, this is a problem that we really need to be talking about, and coming up with things that they think that they can do. And the reason why I'm optimistic is not because what they promised to do is going to be enough. It isn't. It's about 10% of the way to where they need to go.
A maximum effort is 10% of the way.
No. The effort that people have committed to is about 10% of what
that's
they
what
need.
I mean, yeah.
Right. So they need to have an effort that's an order of magnitude larger. But how is that going to come about? Well,
possible, realistic. Let's just say realistic. Of course, anything's possible.
Right.
Is it likely?
Likely is difficult.
Is it likely?
Conceivable, plausible.
I'm not saying conceivable. I'm saying.
Oh yeah,
likely.
we're gonna trade adjectives here.
Yeah. Possible, of course.
let's go back to the ozone hole,
Yeah.
right? When people said, well, look, your spray cans are causing a problem. There's going to be depletion of ozone, and we have UV, and it's going to be a disaster. People at the time said, well, there's no choice. We have to have refrigerators. If we take away refrigerators, people across the world, millions of people will die because of rotten food and bad medicine. They said, we can't use a different propellant in our spray cans because this is really the best one that we can find. But it turns out that none of those things were true. Because as soon as you really start to put your mind to it, we're smart people. We have a lot of smart people who are thinking about these things. And once it's advantageous for people to find reasons to do it better, they do it better. Right? So the replacements for the spray cans were found very, very quickly, within a decade. The replacements for the refrigerants were found as well. Fridges became much more efficient because of other engineering. Nobody died because of no fridges, because of no CFCs. In fact, fridges got much cheaper and used much, much less electricity than they used to. In fact, I think just in the US, the efficiency of fridges is enough to have saved 10 coal power plants, right? Just from that one change from what it was in the 1950s. We can be smart when the incentives are aligned. Right now, they're not. Right now, the benefits of burning coal and oil and natural gas accrue to the people that are burning it, and the costs are down the line. The costs are on another continent. The costs are to another generation. The costs are to a different ecosystem. And because those things are not aligned, people make bad decisions. Societies make bad decisions. But societies can change enormously.
Can they? I mean,
okay.
Can they?
Well, here's another example. New York City, 100 years ago, 100 bit years ago, had a horse problem. Too many horses, too much muck, too many dead horses that were clogging up the streets. Traffic was much worse then because the horses would die and they're so large. You'd have to call in a crew to take the dead horse out of the road so that the traffic could move again. The amount of horse manure was such that people were even planning on elevated sidewalks so that the manure would be kind of underneath and you wouldn't have to see it. Right? That was an adaptation to a pollution problem. Yeah. But with the advent of both electrification and internal combustion, people saw very, very quickly that there was a better way.
So technologically, windmills, which are getting cheaper and more realistic, could gradually replace fossil fuels.
Yeah, so wind is a great resource, but it needs a lot of space. Yeah. So you can't have windmills in Manhattan to provide the power in Manhattan. But you know what? North Dakota has a lot of wind and not a lot of people. But it turns out that the grid in New York is not connected to the grid in North Dakota. Right? The grid in Arizona would be able to provide enough solar power for the entire continent. Except that the grid in Arizona is not connected to the grid in North Dakota or to the grid in New York.
Yeah.
These are technological issues, and we could design things better.
And not impossible to connect these grids.
There is no law of nature that says that Arizona and New York should never have a grid. Yeah. Yes.
Mm-hmm. So much more massive sort of planning could. Well, the number the thing that just keeps haunting me is this 2% is 10% of what needs to be done. That's the one that's really, making me wonder what you could say about what that other 90%. How likely it would be that we can. How would we begin with that 90%?
Well, you begin with the 10%.
Okay. Okay. So have we begun with that?
So we are beginning with that. So in the US, we've actually cut emissions since 2005. Yeah. In Europe, they've cut emissions since 1990. Germany, the UK, France have all cut emissions quite strongly. Japan was cutting emissions, but then with the tsunami and the shutdown of their nuclear plants, is no longer. They've gone up again. The interesting thing about Paris was China and India agreed that they would cut emissions eventually, which up until now they've never agreed to do, because they were always
That's pretty
claiming
colossal. No?
that no, we have a right to develop, which they do. We have a right to pollute because you've been polluting for hundreds of years, and why should somebody born in China not have the same rights to pollute as somebody born in New York?
That's
which
so
on an ethical basis is very hard to argue with.
Yeah.
But they've agreed that they are going to cut emissions by 2030 or something. So it's still in the future. But I think that once you start with the 10%,
Yeah. Mm-hmm.
and this happened in all of those other cases, people find good ways of doing things, and that technology gets shared. That way of organizing gets shared. That concept gets shared. Mm-hmm. It's not always about big planning. It's not always about central command and control. But good ideas do spread, right? And they spread because people like us talk about them. People like you listen to them.
I like the grid idea a lot. Right. I like the Arizona grid idea a lot.
Right.
That's an excellent idea. I don't know if people in Arizona would love it, but
they have sun, and, and we need power.
Yeah.
There should be a trade there.
Yeah. Is anyone in the United States working on power distribution in that way?
Oh yes.
And
so people
can
really
that kind of thing be legislated? Really?
It is. It does require legislation.
Tricky.
It requires the states to work together, and they don't always work well together.
Yeah.
But people are certainly thinking about these things, and this is what gives me hope, right? Because I've been working on this topic for 20 years.
Yeah.
At the beginning, the questions that people would ask me were always, so is this global warming thing? Is this real? Do I need to worry about that? And I'd say, well, yes, it's real, and yes, we have to worry about that. And go, oh, okay. Now, unless it's a staffer from Congress, I never get asked that question. The questions I get asked are much more along your lines. What are the actual solutions? How do we deal with this grid situation? How do we deal with making better, cleaner and more efficient buildings? How do we better organize transit? How do we do this? How do we do that? How do we connect air pollution problems and climate change problems so that there's a win-win solution? People are asking great, deep questions.
Power, I can understand generating energy, which can be done in various ways. What I find hard to figure out is things that are irreversible, such as water, running out of water, or Brazil, which got most of its water from the rainforest. Rainforest isn't there anymore. It's not going to grow up again really fast, so they're out of water.
Well,
because they came from the clouds, not from the rivers. No.
Well, yes. The water does cycle. You know. Deforestation, which you're alluding to in Brazil, is a really big problem. But actually, it's slowing down a lot. The rate of deforestation was much worse in the 1970s and 80s. So now it actually has slowed down because they realize that they're in fact using the rainforest to produce clean water, to produce services that they require. So there are shifts, and in the tropics, deforestation is the one contribution that they're making to the problem that can be slowed and reversed. What are you doing?
I've heard this rumor about juggling, and I just feel like, you're such an excellent verbal juggler. I mean, I'm just kind of in awe watching you kind of go, okay, yeah, but if this, then that, and then how to keep all of these things going. I think for me, this kind of thing is difficult, and I'm just thinking of Scott Fitzgerald, who gave such great advice to writers. He said, and it reminds me of the dilemma that I'm in at the moment, which is, there are. He said, try to imagine that you're going to hold two opposing ideas, and they're both actually totally in oppositional and both totally true, and try to be able to hold both of those things without going crazy. So I feel, in a way, this, this terrifying slide to, apocalyptic things, which are, you're sort of, I don't know what your nightmares are like, but mine have big waves in them, and they have, everything is drowning and fire, apocalyptic things. And there's enough things in the world to make you think like, well, that is the giant story that we're living, And on the other hand, I believe in solutions and doing things about things. I mean, that's, what my work is about, is looking at something and trying to make it work.
Right.
And so, anyway, we're gonna open it up to you in a second. But would you mind just taking a break and showing us how you do this? Because I hear you actually can do it. No, not with a microphone. Also, like try to juggle the mic, 2 mics and 3 apples.
No, that would be tough.
Yeah.
As long as people realize that this is not actually any kind of show.
It's not?
And
okay.
in fact, all it is a metaphor.
Yeah.
Right? So just think of this as a metaphor. We can...
whoops. That's also a metaphor.
That's an awful metaphor.
Yeah. That's awesome.
Okay. Yeah, so, you do juggle. You can go around, you can, things can go up and down at the same time.
Ooh, nice. Oh, nice. Ooh, yeah, bravo. Hey.
So this apple was energy solutions, right?
Mm-hmm.
This apple is the science, mm-hmm. and then this apple is you, right? It's society, because it's not, none of these things are going to change because I say something, or because my science, I publish something in Nature, and it might change because artists talk about this and embed this within their work. But mainly it changes because society changes, because the kinds of things that were acceptable 20 years ago are no longer acceptable now, and the kinds of things that will not be acceptable in 20 years' time are some of the things that are acceptable now. And that shift is one that is driven by individuals and by families and by communities. And it isn't a top-down shift, it's a bottom-up movement. And that's that third apple. And that's the one that really hasn't yet dropped, even though I might actually have dropped it. I'm not quite sure.